go to advantages of friction. Now, 1, friction enables us to move from place to place and also to stop walking after getting started. 2, friction is utilized in belt drives. It prevents belt slip. 3, friction assists in the transmission of power in clutches. 4, friction is employed in the braking system of automobiles, where it brings the wheels to a stop. 5, friction is employed in tightening of bolts and nuts and in screw jacks. 6, friction is exploited in the propulsion of the car along the road. 7, friction is utilized in the grindstone to sharpen chisels, cutters, and knives. Next, we go to disadvantages of friction. Now, where shafts run in bearings, friction absorbs energy, thereby reducing the efficiency of machines. 2, friction generates heat in automobile engines, leading to engine knocks. Now, quite a high proportion of the kinetic energy of the moving car is used in doing work against friction at the brake drums, with the result that there is a considerable rise of temperature of the drums after heavy braking. Now, 3, friction causes wear and fail in machine components, e.g. brakes, car tires, and shoe soles. 4, friction reduces speed of bodies in motion. Now, the next item we'll talk about is the methods of reducing friction. Now, a considerable amount of design ingenuity is devoted to minimizing or eliminating unwanted frictional resistance. Friction, if unchecked, will affect the efficiency of the machine. Friction can be reduced by 1, the use of ball or roller bearings. The friction which these bearings will stimulate, that is rolling friction, is far less than dynamic friction, which could have resulted without their use. Now, 2, friction can be reduced by streamlining the body shapes. Now, friction can be reduced by streamlining the body shapes of materials or components or of machinery. Now, to the shapes of the fluids or mediums through which they operate. Examples of components that are streamlined are aeroplanes, ships, boats, submarines that look like fish, etc. Now, friction can also be reduced by lubricating the surfaces in contact. And now, in a modern car, for instance, the complicated lubrication system has the dual function of keeping frictional forces to within acceptable limits and of dispersing the heat generated by these forces. The introduction of lubricating oils, grease, and other contaminants separate the mating surfaces by introducing a thin film of oil. Consequently, when the surfaces slide upon one another, the force of friction will be due only to shearing of this film of oil and not due to actual contact between surfaces. The thin film of oil is less than 1/1000 of an inch thick. This action greatly reduces friction and is often exploited in the lubrication of shafts, turning in bearings, and in all parts of machines where relative sliding will otherwise give rise to excessive heat. We will take the angle of friction. Now, if a gradually increasing force, P, right, is applied via a spring balance, all right, to a rectangular block of wood resting on a smooth horizontal board. Look at the diagram. Then, at any instant, F, which is the frictional force, equals P. Are we there? Until F reaches a maximum value. Any further increase in P will immediately cause motion in the block. It is clear from the figure above that four forces act upon the block. The force P, the weight of the block, W, the induced reaction, Rn, are we there, of the surface, and the induced frictional force, F, are we there, which equals mu Rn, are we there? The induced forces, that are forces acting on the block by the surface, that is Rn and F, Rn and F, are we there, may be considered as the two components of a single force designated R1. Are we there? Look at this figure. That's the free body diagram. Are we there? The resultant R1 is inclined at an angle phi, pronounced phi, PHI, inclined in a direction away from the direction of sliding. That's phi is inclined away from the direction of sliding. The angle phi is known as the angle of friction. All right, are we there? Now, if we consider tangent phi is equal to, tangent phi is equal to opposite all over adjacent, which is equal to mu Rn all over Rn. Are we there? Tangent phi is equal to mu Rn all over Rn, where Rn and Rn cancels out. So the tangent of the angle of friction is equal to the coefficient of friction. That's tangent phi is equal to mu. Now, the use of the angle of friction often simplifies the solution of frictional problems, especially when the hauling force is inclined at an angle to the horizontal plane.